Hello, and welcome to this video on partial fractions. We're working with division of polynomials, and we want to find an integral by using partial fractions. Now, we notice that before we get to partial fractions, we can perform long division because we have a quartic polynomial divided by a cubic polynomial. So when we perform long division, we have that x to the 4 minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1 is equal to x plus 1 plus 4x divided by the cubic polynomial, x cubed minus x squared minus x plus 1, meaning that when we perform long division, the residue is 4x. Then the integral of the function we're working with is the integral of x plus 1 plus the integral of 4x over the cubic polynomial. So here we write the integral of the quartic polynomial plus 1 over the cubic polynomial is equal to the integral of x plus 1, that's x squared over 2, plus x, plus the integral of 4x divided by x cubed minus x squared minus x plus 1. And to find that integral, the integral of 4x divided by x cubed minus x squared minus x plus 1, we're going to use partial fractions. And I forgot to write the dx over here. So let's write dx equals that. Okay. Now, when we work with partial fractions, the idea is to write a quotient of a polynomial of degree less than the polynomial of the degree of the polynomial on the bottom, minus x plus 1 in this case, as an addition of fractions. And we're going to see that this addition will be negative 1 divided by x plus 1, and then we will have plus 1 over x minus 1, and then we will have plus 2 over x minus 1 squared. We will get to see how to find that decomposition shortly. Then from that decomposition, we will be able to tell that the integral of x to the 4 minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1 will be x squared over 2 plus x, and then we take the integral of this term plus the integral of this term plus the integral of this term. Because the integrals are linear, the integral of the sum is the sum of integrals. And those integrals are very easy to find because we have minus 1 times the ln of the absolute value of x plus 1, and then plus 1 times the ln of x minus 1. And for the last part, we actually end up with minus 2 over x minus 1. And then plus a constant c, or let's call it k, that we don't know, so that we get to x squared over 2 plus x plus the ln of x minus 1 over x plus 1 in absolute value, and then minus twice 1 over x minus 1 plus a constant k. So let's see how we can get to this decomposition. But from that decomposition, the result of the integral is right here. Now we know that. Okay. Now to get to the decomposition, we start by decomposing x cubed minus x squared minus x plus 1 into factors by factoring out that cubic polynomial. And that cubic polynomial can actually be factored out as x plus 1 times x minus 1 squared. There are various ways to get to that decomposition, but that decomposition is true. So what we have is that 4x over the cubic polynomial can be written as a constant divided by one linear term plus a constant divided by the linear term x minus 1 plus a constant divided by the linear term squared. We have as many addends as the degree of the polynomial indicates, and the addends look like constant divided by something. The first something is x plus 1, and there is no powers of an x plus 1, so x plus 1 shows up once as a denominator. But then x minus 1 comes with a power 2. So we generate a term b over x minus 1 and then c over x minus 1 squared. That's how the partial fraction decomposition of this function looks like. So we want 4x to be equal to, and over the cubic polynomial, to be equal to, and then we take the common factor of those things, and that's exactly our cubic polynomial. We multiply x plus 1 by x minus 1 squared. And on top we have a times x minus 1 squared, and then plus b times x plus 1, x minus 1, and then plus c times x plus 1. So we end up with 4x equals a times x minus 1 squared plus b times x plus 1 times x minus 1 plus c times x plus 1. All right. And the equation we have here has to be true for all values of x, no matter what x is. We should have that 4x equals all the expression on the right-hand side, the expression that contains a, b, and c. In particular, we have to have that equality for x equals 1, for x equals negative 1, and for x equals 0. We should have that 4 equals a times 0 squared, that's just 0, plus b times 2 times 0, that's just 0, plus c times 0 plus 1. Oh, that should actually be 1 plus 1. So 4 equals c times 1 plus 1. So 4 equals twice c, or same thing, c equals 2. When x equals negative 1, we get 4 times x is negative 4 equals, and then we have a times minus 1 squared. And then b times 0 times negative 2, that's 0, plus c times 0. So negative 4 should be equal to a times minus 2 squared, that's positive 4. This gives us that a is negative 1. And then from making x equal to 0, we get that 4 times 0, so 0 should be equal to a times 0 minus 1 squared plus b times 0 plus 1 times 0 minus 1, and then plus c times 0 plus 1. Or same thing, a equals a, 0 equals a minus b plus c. And a is negative 1, b is a number we don't know, and c is 2. So b should be equal to 1. That way, we get the decomposition we have that I showed you earlier. 4x over x cubed minus x squared minus x plus 1 is negative 1 over x plus 1 plus positive 1 over x minus 1, and then plus positive 2 over x minus 1 squared. Okay, So to summarize what we did, we have here that we performed long division first because we had a quartic polynomial divided by a cubic polynomial. And then we said that if we had a decomposition for x over the cubic polynomial, then we would know the integral is this, and then we justified the decomposition. In general, you wouldn't know the decomposition beforehand, so this step would be would show up before we find the final answer. All right, thank you for watching. If you have questions, make a comment and I will reply. Bye-bye.